Good afternoon, sir. Next speaker is Dr. Professor Subrat Kumar Panda. Professor Subrat Kumar Panda has been working as a professor in the Department of School of Mechanical Engineering at NIT Rourkela. His expertise is in the field of computational and exceptional experimental solid work as well as smart composite structure. He has already handled few research projects from the different sponsoring agencies DST, DRDO, and AICT. So, please welcome, sir, on the behalf of the organizing team, I, Dr. Smitiruva Pradhan, welcome to this platform to deliver some of your expertise and for which we will gain some knowledge. Thank you, sir, for coming, accepting my invitation, and coming for the deliberation. Thank you, sir. Sir, please, you
Thank
can
you,
start
madam.
now.
Is it my? Is it visible? My screen is visible.
Yes, sir.
So, good afternoon, all of you, and thank you, ma'am, for giving a small and concise introduction. And I don't want to waste much time because I have taken 15 minutes from organizer because they have given me a chance to speak on a topic digitwin. And I already discussed something in the last talk, and a few things I want to discuss. But again, as the time is very small, and I got very less time to prepare. Although when I'm saying the preparation point of view, if I'll say rather I without wasting much time, if I'm going to digitwin and whatever the kind of industry application. So before going to the digital and digital application, I want to speak a bit on that. What is exactly my plan of talk? And I must be thankful due to this short period of time. Just last few two days before, the organizing team request me to give a talk on digital, and although I have a very small kind of experience in the DigiTwin, we have not worked hard to that, very hardly. But a computational, since we are working in the computational field, computational material modeling or computational mechanics of solids or computational continuum mechanics, it is you can say it's one of the tool under this DigiTwin. It comes under one of the tool of that. So that's why accepted, and I also thankful. I want to take the name of my group, those who are working or those who have helped me to make this possible to make this all presentation. I must thankful first Professor Nitin Sharma, who is working in KIT University itself. He has something with him to share with me, as well as Professor Prakash Ghosh, me and Nitin, and another professor. Chetan Hirwani, who worked in work now he is working in NIT Patna. We at all as a group we worked for a Bokaro steel plant. I'll show some work whatever the kind of it's relevant to not exactly the digitwin, but how it is relevant to the digitwin. We'll discuss of that. And first of all, I'll discuss a few consideration regarding uh, what are the components of the digitwin and to whom we can say digital twin or basically the name suggests it's a digitwin. Anything it may be utilized in healthcare. It may be utilized if I can share some and I need not to share again. If you just type on Google digitwin applications in healthcare, you will find now work is going on to find your twin, or any person or any patient goes to the hospital, and people are trying. And just a few days before, in December 10 or 15, something MIT has launched one. under this AI platform, people can write projects and expression of interest. They can EOI. It is asked for that. If people are working in AI ML or particularly AI, is mostly application of artificial intelligence. Again, this artificial intelligence is only to utilize or extract data. There are four major perspective you can say. One is the data, a lot of data you need if you want to have a twin. If I want to make a mobile phone and I am trying to get where the faults and how it is going to happen, and if I want to correct those faults before it happens, so I could have do the same by doing two different kind of things. The digitwin is the advanced one. Wherever now today what we do, now people those who are working in mobile industry, or you might have seen some mobile watches or any electronics gadget, they have their own like Samsung, or if I'll take some name of the companies, those who are in the electronics world, Samsung, Philips, LG, they have their own service for the service of all these appliances. Their service engineers are there. They have been trained. It is not only in the electronics industry. If you go to the automobile industry, if you go to any other industry, if you go to the steel industry, since I am talking about this because these are households we are utilizing every day to day life. So we have a people, or you can set up people there available to give you the solution if you have any problem. But digitwin is one kind of thing which will create before it will launch to the market, or if it is already launched, it could have a similar kind of before the preparation or final outcome. If you can have a lot of data or the images or the models, then you can make the things as same as it is in market, or what is in the real time. You can have a virtual kind of a similar product each. The basic idea of the digitwin is like that. So in this context, I'll try to focus a few keywords of this digitwin, then how it is applicable to, and is it possible for everyone is can contribute to that? Yes, it is possible. So how it is possible? Not exactly the 100% you may or may not do the digitwin work, but you are whatever you are doing, it could be a part of that digitwin, or you are just you can say a small extra aid can you can add to another aid to that digitwin what is happening surrounding in your surrounding. Now in this context, there's some few as I said the keywords. So it's a virtual model, what I said, anything and everything which you are using or we are planning to use or it is available. The digitwin is a virtual model designed to accurately reflect a physical object. It may be a mobile, as I said, it may be a mobile, it may be a gas turbine, it may be a whole aircraft, maybe um, any motor or anything or everything. It can be like here you can see some of the images are given. The product as well as a digitwin, a small window is showing the digitwin of the same wind turbine. It can also be defined as a virtual representation. People are working VR and AR, augmented reality and virtual reality. Digitwin is one kind of virtual world where you can collect all the data or some of the data, component data, process data, or everything and anything which you want to do, you can do accordingly. Or you can have those components if you have, then you can say, yes, I can give a digitwin or digital twin to the same object. Like what are the things are required for that? It is composed of three major things. One is physical entity in real space. It's a aircraft, or it's a mobile, or it's a phone, or mobile phone, or it's a television, or it's a washing machine, or anything related to a high-end or high-performing industry, or anything which is day-to-day life. You can take it as a your component, which need to be digitally twinned, and it may be associated with hardware as well as software, and mostly the things it will occur in digitwin utilizing soft data, not hard data. But in order to run this soft, you need some hard. Like if I'm having ANSYS or Abacus, it has to run on a computer. So although the process will be done numerically or in a soft, but it needs a support of hardware to be done. That means you can say it is hand in hand for both and hardware and software to work and to update the things to give a twin of the same object or real object which is available. It may be robotics, it may be aircraft, or it may be or any industry, energy industry, the renewable energy industry. All this industry may use. So some of the examples here it is, as I said, it can do is similar like as you are doing scanning. It's just a scan kind of image, or if you just write in Google also, those who are the butterflies. Let's say the if I'm taking the example of a butterfly, how a butterfly looks on a flower, and where it has to be like your a mosquito comes on our hand or a body, somewhere it just stand and put its hole to suck blood. He utilizes the mosquito utilizes its own, it has its own that sensor kind of thing, and it senses as well as penetrates. Is that also buckles? Sometimes that is also buckling, so they can see the body, or their visualization should be like this way, that where the exact position they need to suck the blood, or they need to use to the nectar can be sucked. Like that they can utilize their some kind of similar kind of images must be built up in their mind, by which they could able to see. And this digitwin will give us the similar kind of idea, what are the components, where uh, the complexities are there, where we can we need to change the things, or anything happens. Like G also in the General Electrical, they are mostly the majority of the aircraft industry. GM, these people are working. G majority a contributor of that. They are planning to develop a gas turbine engine, the whole aircraft. It should, after every flight, it should talk about its health. That means how I have taken this much of I took this flight. After this flight I consumed this much of oil. I consumed the my brakes are were used for this much of time. My flapping wings and static wings are work for this much of hour. Then after that, what is the my health? The aircraft itself can speak about it, either in terms of process data or in terms of speaking data as well. They designed. I heard this one 10 years back in a talk. One professor from IIT Kharagpur, he was associated with that company, and they are working in that. And they are working 10 years back. They are working in this area. It's near about 2011 or 12 like that. So you can think of the digitwin is not a today's work, or just now, because it has been enhanced as the other parameters has been increased in this particular area. As we have started looking renewable energy very highly, electrical vehicles very highly, and also we are trying to a term comes on sustainability. Whatever you are going to like in your this in industry 5.0, the major point is the sustainability. That means whatever the material or design or component we are designing, that has to be sustainable enough, and we need not to produce the products more and more. Rather, we'll reuse those product by implementing or understanding their fault. If any fault is there, then before the fault occurs, if I could able to manage that, then the same physical object can improve its performance for a longer period of time. The same thing has been written over here. This sensor produced, it is mostly associated a number of sensors, and the sensor will give you the either it is imaging kind, or it is, although it is looking like because a image can give you a tells 1,000 words. It's a Chinese proverb. Image can say 1,000 words than a writing. So that's why everything we are trying to show in either in virtual reality or augmented reality, we are trying to show the things, or whatever the in our mind. If we could able to make it in an image form, then it can pass on the idea to the next generation. So what digital twins promise to us? These are digital twin, because we have simulation also earlier. So how they are differ from each other? The people may think of, as I said, many things. You just see the first point: interaction with physical world. How it is different? A continuously digital twin says it's a continuously synchronized with their physical counterparts, whereas simulation talks about only the snapshot of a situation during a simulation. What does it mean? How it is different? Because continuously synchronized, when I am saying the exact thickness, the exact variation. If I'm talking about this mobile, the mobile side, if you could able to see my video, I don't know. If you could able to see this side of the image or this side of the mobile, where I am just having this finger, you have it starts from this end to this end. There are some deep, or you can say another buttons are there. So if I take a snapshot, or if I make it I can do the same model in simulation software by utilizing or giving some kind of if you see the height of this button, so I can draw the same. Whereas if I need a digitwin kind of thing, or if I'm having a digitwin kind of thing, it will automatically, if I'm having some kind of pen kind of sensor, if I'll go on putting over here, it start drawing the thing. Or those data will be generated in that way that if I'll connect everything, then I'll get the exact shape of that. So real time update, yes, it gives, but in case of simulation, it will not give any changes occurs in there. That it's not going to give. So offer a live dynamic view of the system, but it is a static presentation in case of simulation. Like a aircraft design, aircraft wing, aircraft any counterpart of the aircraft, or any component of the aircraft, I'm saying any component of the wind, the turbine, wind turbine, I'm saying any component of a motor, I'm saying it is any component I'm talking about. If any changes occurs during the process, if you are changing any of the knots, bolts, or any shape, it is going to show you in a digital twin. However, it is not changes in simulation kind. Initially, whatever you do, as per the available data, you just component you draw. Then after that, you do the modeling, and you predict. The last point says predicting how changes in raw material costs affect production in production cost, all this, and in manufacturing process. However, in digital twin or digitwin, it says active digital twin of a smart building adjusting ventilation, air, like that. Any like if you are using the battery, sorry, mobile phone, after using the mobile phone for some hour, 30 minutes, 15 minutes, if you are talking, going on talking that phone, the phone battery start on heating, starts up. So how much this heating starts up? Due to that heating, the electronics attached with this mobile phone, that may or may not, we are not saying it is not going to damage every time. Sometime it is going to damage, and how much it is influencing, we can able to see, or we can able to verify by using digital twin. However, we need to give those data initially for the simulation. I hope I could able to make this is little bit clear. Now, digital twin essential properties. What are the essential properties? I am going little bit faster because we have very less time, not much time. So I am trying to, as I said, I'll give some keywords. Then what are the things we did? I will, a very small part we have did, and I'll try to discuss that one. Digital twin essential properties, unique representation, digital model flexibility, and this all comes under like CAD model. From CAD model or SolidWorks model or any model kind of thing drawing, we, because any concept of design starts, it starts with a conceptual design, or it is basically attached to a kind of image or drawing, or a basic idea about how the product look like. Then their digital model starts, which has some database equation, and all these points are necessary to establish. And if we have number of input parameters are more, it will be, the model could be more flexible. We can change the things wherever, or we can make the modification wherever we need. And for the corresponding particular drawing data, we, if we have we could have a better data set or database. Now that data can be linked or interaction. If we can interact those data, we could able to enable, like as I, every time, if we take a small example in how the data link and interaction occurs. In an open loop system, if I try to show or try to say like this, in our day-to-day life, if you most of us, we are using um the what is called washing machine. In automatic washing machine, we need not to do anything. We just put our clothes over there, and the necessary detergent is there. It soaks the water, it soaks the detergent, it will do everything, and finally keep it dry. However, if I'm giving another example, like how it is a simulation and a digital twin is different from each other, and how the digital twin is more flexible in that, or how it the simulation or whatever the simulation kind of work we are doing before the manufacturing or design, how it helps. Like in case of your front load or top load, if it is a automatic machine or a semi-automatic machine. Semi-automatic machine, we need to put some regulator somewhere up to washing. Then after the during the dryer has to, and you might have sensed that if you're in a dryer, if you are not using the clothes, wetted clothes, if you are not putting the wetted clothes in a proper manner, it start the amplitude of the vibration is too high, and it gives a horrible sound, and it is not very stable enough. Then if you will make it all these wetted clothes, if you will make it little bit um, continuous, or some changes you will make, it will start smooth. And at the end, it start, or at the time of washing also, it gives, or a buzzer will be there. It start giving you the sound that yes, the work is going to complete, yes, the work is going to complete. That means that kind of buzzing or any alarm has to be there. Or if I am designing something, any object if I am designing, if you could able to find this alarm from somewhere before the system completes its whole process, then it will be easy for us in because a lot of cost is being involved, a lot of design, human time has been interacted with that for this final product. And it will give you a better understanding, or you can say a comfort kind of design can be given at the end. And this can be this data, and if you can link and interact, you could have a better kind of understanding. Like this defining feature in a is the data link upon two-way. This link enables user to query. A two-way is happening the whole when it is totally automatic. That means it is sense, it utilizes, activates, and it completes the work. But in semi-automatic, it doesn't happen. A human interaction has to be there. Without a human interaction, it will not happen the next work. It will just give the buzzer, and it will stop there. Once again the human will, or again the person or any interaction will occur, then only the process will start moving further. Like this, a similar kind of thing has been shown here. Like today, most of the, like Tesla or any most of the vehicles are preferring for auto parking and auto mode kind of thing. You saw, these are the very small things being attached. As I'm going on increasing, the designer is going to increase the number of facility, the whole cost of the things will increase. So that's why the mostly, again, if you have everything automated, if you have seen the old hero book, people are using hero book now, hero book scooter, everything is gone. Now everything is comes under this activa kind of scooter, where everything is automatic. And when if it is automatic, and the whole thing is there are some benefits as well as some counterparts as well, you can say. If there is a problem, you have a complex design, the design has been, if it is automated everything, then complexity increases. As the complexity increases, you need a better skill to maintain that. And for the better skill, you need a skilled person to handle the same. So all these are correlated with each other. Then slowly all these courses we are discussing here, and from this platform, we'll learn something, and we are trying to implement. Slowly the whole world will switch from set one set of understanding to another set of understanding. So digital twin is also one kind of set of understanding which tries to implement everywhere, including our healthcare to our bigger industry. So it is mostly works on the synchronization. It's about ensuring the digital twin and the represented entity mirror each other and closely as possible. A frequency or speed, whatever the digital twin we are talking about, all these frequencies and speed we need to have a clear understanding on that. If any few seconds here to there, then it may create any problem. So it has to be very. Then fidelity is the one degree of precision accuracy where in the virtual representation. If any change in that, if it is not the fidelity is not be clear, if any document data information will be uh, again the information we are getting or the lot of information, if we have lot of information, that can be only converted. If without any information you cannot generate such kind of thing. For that we need the information. In order to extract the information we need a system to extraction of information. And if the informations are correct, then we have a better system. If there is a incorrectness in the information, then it may create a incorrect kind of solution to that. And incorrect solution creates a incorrect kind of design, and which may create a catastrophic failure of any system. So digital twins basically are four class. As I said earlier, you may have a small thing, two bigger things like process digital twins and system digital twins and component digital twins, product digital twins. And mostly the work we did till yet, we are under this component digital twins majority in our area. Whatever we are doing, we are component digital twins, not system digital twins. Like aircraft components we have designed aircraft component in under the simulation, and we are trying to convert from the simulation to digital. And how, I'll talk at the end of my talk. I'll come to that. So out of these four, again, the first type or digital twin types, as I said, component twins or parts twins. Component twins are basic unit of the digital twin. The smallest example is the functioning component. Part twins are roughly any part. If I'm talking about here, one image has been given. You see the original one and the twin, which is the dotted one or the image which has been created, which can be explored. Also, we do in CAD model. If somebody has already involved in design application, like patent and design application, two type of things people are doing now. Design application, we need to give the exploded view of whole object which need to be designed. And there you can have this CAD model, individual components here also. But this individual components with animation, if I'll add, is the exact value and the animation, if I'll add, then the component to it can be converted to a virtual understanding to whole object, or either it's a aircraft blade you have designed, or any mobile you have designed, or any small any component. Let's say as we have designed a stressor device, and we gone for both a utility design as well as, sorry, a utility patent as well as a design patent. So and the design patent we normally give similar kind of images without any animation. So if I'll add those animation to that, their orientation, everything, then it will be converted to a component, and those are the components and parts of the twins which has been shown here. So digital twins, asset twins, what is that? No, a product, the whole product, from a component to a product. If I'll say a physical asset, if it is given, it's shown a gas turbine engine. Here it has been shown from the gas turbine engine to here. If you see the digital twin, the physical to what are the other things you need? Now, fleet aggregate data you need, operational history you need, maintenance history you need, because operational data and maintenance history will give you how many times it has been maintained, how many flights it has been taken, how many hours it has been run. And from there, from beforehand, you must have to have a CAD model. You must know the dimension properly. After one flight, the dimension is maintained same or not, you will know from the maintenance. If a circular diameter is there, or you might have seen the, if you have used your household like pressure cooker, all of us we are using, and the pressure cooker use a rubber. The newly brought pressure cooker, the rubber, how much it is tight and how it is took some time to be tightened. However, if you use for 1 year and 2 year, it is little bit, the rubber has been extended, or it is almost a saggy kind of behavior. You might have seen this rubber. So you need not to adjust, only you have to adjust that the grooving, the rubber has to be within the groove. Sometimes it comes out because of the length has been increased. So that's kind of thing after the utilization or reutilization, how these dimensions has been modified. If it has not been modified, then you need to understand that how much it is. It is 1 mm, 2 mm, 3 mm. That means how the original dimension has been distorted from the, it has to be maintained some diameter. It is distorted or not distorted. We have to ascertain that before the design of the thing, or before the design of the product, or before the market, it will be marketized to the product. Now the next one is a system twins, which has been shown. A system, whole system from physical and virtual, a robotic arm, and their corresponding operational things has been shown over here, which works on a Microsoft computer vision. It is working, and the same thing can be done under virtually as well. And you might have seen in the and now this robotic arm operations or medical applications, a lot of things are available over there. And robotic arms are also being utilized in the nuclear operations also, to whenever there is or surgery, the robotic arms are being utilized. There are various surgeries are being utilized by that. So you might, this digit twins already there, people are already in healthcare, many places you will find, as well as the high end manufacturing, they are also using the same. And this is the only process by which we are asking people to understand what is digital twin. And when I'm saying to you, as well as I am understanding, things is occurring. Am I audible? Am I audible? Hello?
Yes, sir, you're audible, sir.
uh, Visual, you can able to see my slide.
Yes, sir, it is audible as well as visible.
Okay. Process twin, similar to the process twin system working together to solve a larger goal. I'm little bit going now. I'm going faster. Like the whole process, the process parameters are from the production line. Whole production line can be digitized. Digitwins can be, and what is the basic benefits? One is the cost and risk reduction, improved operational efficiency. As we have discussed many examples, I'm not going very details. Optimize R&D, because if I'll go on increasing the R&D, the whole cost of the things will increase. Like one example, if I'll give, in the how this optimized R&D improvises the cost. If you remember the nano car, which has been when it was launched first time, the cost was around one lakh or within 2 lakh, and it got not got the similar market because of the salary of the people, those who are going to buy. It has been increased from fifth pay commission to sixth pay commission mostly, due to which people have got enough money and they go beyond of the cost which is available there. At that time, it is the lowest price car which was available. And how a person or a company could able to do that? Because they have given during the launching of the same, Ratan Tata itself, said that how they have reduced the cost. They have reduced the total R&D cost on that. Only they have taken some tests, few front to front test and some other tests they have did, by which the total nowadays, if you see BS6, BS6 or BS7, likewise BS6, it is coming. All you must have seat belt, you must have airbag. There are some safety features has been increased. So like that, the safety feature. If I'm going on increasing the safety feature, let's say if I'll have a high-end car, any high-end car, it is cost around, it starts from 35, 40 lakhs or 30, 37 to 57 in between. How many times you have heard that there is a very rash, due to rash drive or due to a heavy accident? This high-end cars, the people, those who are there, they 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 faced a lot of devastating situation. It is almost the percentage are very low. In our India, I'm talking about. I'm not talking about others. I don't know about others. But what is the problem with the Indian cars or low cost cars? what I know, what my knowledge says, if this 5 to 10 lakhs or 15 lakhs cars which are been developed, within that or 5 lakhs mostly, they have the sensors which has been utilized to open this airbag. If it is a frontal collision, and if it is more than 80, then it will be occur. And if you see, nowadays, if you are going more than 80, there are mostly the network of roads I am using. It is every roads are less than 80. If it happens, then there might be chance that my airbag may not open. If there is a frontal collision and if it is less than 80, it may be possible that it will not open. So you can understand my safety. So again, if I'm increasing, then how it will open? So this optimized R&D has to be done. If I'll do that, then I can change the sensor. If I'll go for that, then I have to give extra cost, like automatic parking. At the time of automatic parking, it has to be sensed. It has to be sense all the things. If something is there in the back, like people are working in robotics with the hurdles, if there is a hurdle or not. That means from the image it could able to recognize there is a hurdle or not. If it's a hurdle, then what is the angle? How much angle it could able to cut? Like that, when it is going on a small short, nowadays it is coming in either in YouTube or in Facebook or anywhere you go. It shorts are coming. People are doing giving some shorts. Those short videos also you can see. There are showing some automatic how the cars do with the cruise, automatic cruise. It is going on. So all these features are available only because of this R&D. If I'm increasing that, then the cost will go in high, and increase requirement of time, like that. All these things, and end life will improve, all this product life will improve. Those are the part of that which need to be understand. So now these are the some innovative catalysts for the digital twin and operational improvement. By this, if we have, this will give the some kind of benefits to the then interoperability is that to useful the digital twin must work in a variety of enterprise applications. While they usually start with CAD and PLM, which I have already said. CAD, we are using CAD and PLM production, product life management, and enterprise resource ERP planning, and MRP material requirement planning. All these systems can be digitwined, or digital twin can be these are not necessary further. Is a single solution or a single hand solution it can be given, and again the cost will, so automatically the cost will high if it is going to take every responsibility. So here one example has been said from infrastructure, civil infrastructure. If it's a building is there, so what are the information you need to have exact, like the bridges we are making, the buildings which have been made, and how they are okay. If they are okay or not, these digitals also can be prepared. If I'm having a information model technology, data processing technology, data acquisition technology, if I'm and interoperability solutions, then I could able to do the same thing whatever I am doing for other industries as well. And so what are the challenges? Data management first. It is very difficult to manage the data, and under this managed data, cleansing often needed to make data from CAD model, IoT sensor usable to the digital twin. Because as you are going on increase the data, the sometime like your system is going to hang. Similarly, your whatever the system, what is the capability of the system, according to the data management is very much essential. And what are the data we are using? They must be secure enough. So we need to see that. And the internet of things, due to the development of IoT also, it sometimes usable, or these clouds are available, we are having this data in the cloud. That is also possible. And it is the challenging part for us to see that. Us, when I'm saying the design engineers or the future engineers or the future people, those are future manufacturers, they need to see all these points, and they are looking into that. These are the challenges they have found. So similarly, in this particular context, the system integration, how it will be integrated, it is properly, it has to be taken care. Then supplier collaborations, complexity, as well as complexity of the design. As I said, as I'm going from a small component, the whole system. So there may be complexities going on increasing, and the software we are using for the components, they may not be sufficient to give the whole system information. So market and industry, if I'll say, it may be physically large projects, mechanically complex projects, and power equipment. These are the digital markets now industries are working, or mostly the digital are mostly preferable. If you see the digital markets by 2020 last, how the market has been taken, the residential and commercial are mostly, and automotive transport. The first industry is automotive and transportation, which I have already said. Healthcare and life science, we have a part of that. And agriculture, now it is slowly the agriculture is going to little bit more into that. Retail and consumer goods, not yet, still it is in a process. And I'm trying to show some agricultural industry, how the this agricultural industry is useful by using digital twins. In our India, it is although it is not been fully loaded, but still people are working on that. Very small amount of people, or a small number of industries are working, but still it is there. Digital in agriculture, like intelligent silos, drones. But drones are being adopted, or to have a user friendly, because people are working towards smart farming. And when they are converting from the smart farming, and the labor cost is going on high, and other input cost is going on high, so people try to find it, the things, either it is they need a small number of people, and a high amount of technology to be used. By that, the total cost implementation, initial cost may be high, but the total cost of the implementation is going on decreasing. And in that context, if I'll give an energy, when I'm saying energy application, before going to the agricultural industry bit, I'll just say, now government is giving a lot of every now it is in available in everywhere, or advertisement is coming, a lot of subsidies on rooftop, what is it called, mm, solar power, or solar panel, rooftop solar panel. Tata Power is giving on rooftop solar panel. If you're going for rooftop solar panel, they are giving a huge subsidy. And if you go for that, your renewable energy consumption will be high, and the total energy, because it is looking towards the sustainability again, and it is trying to convert the things in digital twin. It's a one component of the digital twin. Under this digital twin, the whole power system in the in a particular, let's say, if I'm staying in NIT Rourkela campus, similarly small campuses, or small gatherings, the whole community can be uh, they can be found out on a single laptop or a single system. They can be found how the power is going on, where the power shortage is there. If there is any problem, this digital can give a solution to a community to that. So at that time, that's why you might have seen the earlier example where it has been shown, the residential and commercial applications, the digitwins are been more marketized. And particularly this energy kind of point of consideration, if I talk about, then it is one of the major example of that. So evolution of digital twin, or if you see how the agricultural sector has been improved, the agricultural one, agricultural two, these are all, it has been seen by us. Most of the people, those who are in the present here, we all of us seen similar kind of situation. And this is the third one, which is not much in the, I don't know, in Eastern India, there are similar kind of, but the first one and two, this is okay, but three I don't know regarding the application. But here in western side also, people are using, those who are having a bigger farms, and vertical farming also having one kind of this agriculture 4 and this agriculture 5. How it is, agriculture 5 is being adopted mostly without having this 4 and 3. Not much use of 4 and 3, but 5 is being people are using this mobile, and by doing that, small innovations you might have seen. I don't know if you have seen it, is okay. So digital twin technology in agriculture, if I say, it will help in enhancing productivity, again the sustainable practices, economic efficiency, because sustainability and economic sustainability is one term, it's a buzzword, and economy as well as the ecology, uh, this two cannot be very they can they in generally they don't go hand in hand. Your economy will increase, so automatically the ecology, it will have to hamper the ecology. If will hamper the ecology, if will may use this word sustainability at the time, if will use this word sustainability, this sustainability sometime what happens, uh, this sustainability is the term which is makes the balance in between the economic and this environmental stewardship. Or environmental stewardship basically talks about the ecology of that, and all these four things impact the global impact or creates this global impact. The what is the digital twin technology in agriculture is, as already it has been said, increase productivity, resource efficiency, economic advancement, environmental sustainability, and enhance quality of the traceability and global food security. So because food security, why I'm showing or why I'm discussing one, I was in a talk in the last day. I was sitting this blue economy. I do not know earlier about blue economy. And blue economy basically talks about the seafood and seafood consumption. As if you have, if you know, the non-vegetarian people have been increased so high, and fishing is abundant fishing is going on, and due to which the ecological system of the marine ecology is going to they are now facing a lot of problems. Now it has to be maintained this ecology. That means the people, those who are there, as the number of people are increasing, total land area decreasing, and the agriculture has to be improved so high that they need to feed all these people. And at the same time, there are vegetarian people and non-vegetarian people. For the vegetarian people, when we are talking about this innovation, non-vegetarian people also, people are starting thinking how it could be the ecology has to be maintained without hampering the taste of the people. So these are the some advancement has been shown over here, like planting, maintaining, and harvesting. These are one. These are been now nowadays it has been mechanized, or you can say semi um, semi sorts. Although in kind of automation, those are bigger. They are using fully automated things. So livestock monitoring, like digital twin agricultural industry, livestock monitoring, although it is not very much in agriculture, like livestock monitoring basically talks about the those who are in the dietary kind of things, poultry, dietary, or like enhanced animal health, animal kind of things. Those who are participating to that, these are also been you know, there are people using. To have a chicken the eggs has to be in a to chicken pigs, or what's it these are small chickens which has been first initially incubated. The people are working on that 5 to 10 years back. People are working on that. Now people are not working, but how to make them, their health has to be maintained, and the a right form of protein should reach the market. These are all been taken care. So during this process also, this digitwin may help in that. And all these conditions, as one here it has been shown for the farmer, those who are working with the a dietary kind of thing, or it is field monitoring management. If those who are working in the crop kind of improved crop management, optimized resource utilization, they can be also help to the digitwin can help the agriculture industry. And digital twin in because as I said, digitwin, and they're not only manufacturing industry, it can utilize the agriculture industry, it can utilize the manufacturing industry, it can utilize the design, the initial part designers, or you can say simulators, or you can say analyzer. Or analysis is the first hand, or you can say as we say in mechanical engineering, mechanics of solids are named as the analysis wing of the design. So if it is an analysis swing, so this swing is also a analysis swing, can give or can be adopted according to the type of industry. When we are coming to the agriculture industry, it can be a farming industry, it can be a dietary industry. We can just differentiate between them. According to that, we can use the terms or the necessity or facility. Like if it is an energy industry, then it will change the energy, renewable energy, either it's a solar energy or it's a wind energy. According to the problem and their corresponding solutions will be different. Similarly, the agriculture industry can also utilize this kind of digital twin. These are the some kind of inputs or input parameter could be utilized, or could be, or it is on process, people are using also. It is not that it is not yet popularized, and these discussions may help us to popularize the thing. And one of the wing we can somebody may think of, he or she can work into that field. So there are some more reduce, how it is reduce the cost, enhance the supply chain. All this industry I talked about under this agriculture. There are applications with some images it has been shown. So now indoor and precision farming also, people are doing indoor farming, like some of the farmings can be done in indoor, or today also it has been doing, particularly one of the farming in India, or people are very much well known in Eastern India or nearby. Uh, mm, Anybody who can say that name? Nothing. No one. Okay. ठीक. I am also not going to say. At the end, I'll ask. So now you just think in between my discussion. So now drone technology in agriculture, it is one kind of, since you can see it can image the, if there is a, this plant is having some kind of problem, that can be, if it is a small area, you can able to see. If it is a large acres and acres people are planting, at that time this agriculture utilize this drone technology to have some kind of understanding from there. And it can give you a survey and ground control points also, and from there you can control your whole thing. If it is system management, if you have a long big estate, you can do that, to find out the soil condition, crop health, environmental factors can be also looking by here. And farm automation, blockchain, IoT, agriculture, all these points can be, these are the some points which can be utilized over here. And this big data analysis, connectivity technology can be utilized, and these are all coming under this. And again, the similar way, if like drone technology, CFD is being a buzzword in mechanical engineering and mechanical, chemical, civil, or you can say aerospace. These are one, CFD is a much more acceptable by many people. And these are the CFD, how being, like here one example has been shown, the CFD computational fluid dynamics is showing how the fluid flow in the turbine cases. CFD, it is a turbine design. If the turbine cannot move, a flow can be given at the exactly, from there the velocity, the designer can give you the value, what is the stress, how it is going to bend, if there is any other problem can be predicted beforehand. Or CFD can be used in other problems, like it helps in, why CFD here it is given, growth in complexity and unsolved engineering problems, need for quick solution of moderate accuracy, not exact accuracy, absence of analytical solution, the prohibitive cost involved performing an efficient solution algorithm, sophisticated and pre-post, like that. If somewhere someplace you need, you can also use the CFD analysis. So here some virtual model or some steps have been shown, or steps has been given. I'm not going to discuss, only the sake of continuity I have given here. Then further, I'm just going to directly some more examples, rather than talking about the CFD and its advantage. Only as I said, here the some of the points has been given, which is known to many of people. Only my to make this continuity, I have added over here. And application of the CFD, as I said, aerospace, automotive, energy sector, everywhere the CFD is one of the component, like your design software, renewable energy everywhere. Wherever the digitwin can be biomedical application, marine or offshore engineering, wherever the digitwin can be, uh, how this digital twins and integration of that. So the integration of the CFD with the digital twins allows real-time refinement of the simulation, ensuring, as I said, those are the areas like aerospace, biomedical, your manufacturing industry. There can be they are a you can say a big shot over there. It bridges the gap between virtual simulation and real world operation, unlocking new opportunities and innovation. And one of the industry is renewable energy or wind turbine cases. Similarly, the melting process application of melting process of iron melting process. There is also CFD can be utilized. It normally gives those who were working in the blast furnace and nearby the blast furnace or steel flow, or you can say after the billet, if the billets are going for reheat furnace, then they are been rolled for small thin plates, or there also the CFD can be used, and we have utilized that. I'll come to that, a part of that, exactly not 100%, but a 4 or 5 slides I have to show. I'll I'm just running out of another 10 minutes. I'll try to finish it up. Now here some this exactly the continuous casting of this whole is given here for your understanding only. Like CFD model analyze the molten steel flow, heat dissipation, temperature gradient, continuous casting process. This inside improve the design as well as distribution of reducing defect caused by the turbulence, because it is too high. Sorry, too the temperature is too high and the corresponding flow it is difficult, so that's why exact real time data to find out is not possible every time, but still we can have some similar kind of simulation analysis can give us give us some idea, and we can compare with the exact values. Fume control system, if there is a the fume gases are very much high temperature, so how to do that, or how to find out are they like environmental regulations to maintain the environmental regulation, what should be the temperature, what should be the content inside the gas, we must know about that, and how much carbon footprint we are going to give. So digital, if it's so just digital in a maturity level, if you see almost everywhere or every single step, if you have the future of digital twin nearly limitless. And this limitless, when it says digital twin, now we are using cloud. Mostly all of us we know about cloud. Virtual, a bit of virtual we know, not exactly. Asset information. Earlier, what happens? This instead of digitwin, we have a twin of anything which comes with a manual, and those manuals are now been converted into computerized manual. And that manual will give you, like if you have seen your, if you have a car, if you have a bike, if you have a TV, if you have a fridge, if you have any electrical appliances too, any household appliances which are having some kind of power transformation, something is occurring, it comes with a particularly manual, and that manual gives, if you look page number 1, page number 2, and how the tire works, what are the what are the dimension, and how to open close, all this some small few details has been given. Now digitwin will help you to get all details in a subsystem. So digital twins are constantly learning new skill capability, which means they can continue to generate the insight needed to make products better and process more efficient. And some research, as I said, what we did here, dimension of RHF according to received data, we did a course, as I said. Initially, when I started, Professor Prakash Ghosh, me, Nitin Sharma, and Chetan Hirwani, Dr. Chetan Hirwani, we all started one small course at Bokaro steel plant. And reheat furnace, I'm not going to exactly give these details. And they have the reheat furnace basically what is if you see this image, from this image, if you just so this is the on this line, this is just a beam kind of structure, you can say it's a bridge. On It's a bridge kind of structure which is nothing but is a skidding platform on which this is a skidding platform, and over a billet will pass. And if you see the billet, when it will the billet will pass through, it is inside a furnace, and a number of burners are there, and those burners start burning to reheat the billet which has been the billet has been made, and to make them before going to the rolling, it has to be first reheat in a recrystallization. Almost all of you know regarding the cold working and hot working, and cold working, some cold rolled and hot rolled. Cold rolled doesn't mean it is under a cooling condition, rather it is in a same temperature but below the recrystallization temperature. And this rolling is being occur before going to the roll. It needs before like if you see the top view, it is looking like in this kind of bed. Now the geometry shows like outer body, inner fluid domain, billet, skid. As I said, this is the billet which is passing through over here. This is the bridge, and these are the burner, and these are the skidder. These are called skid. Every single unit is called one skid. And you see one arrow mark has been given. This arrow mark shows that it will move in this direction, this x, and this y direction. A isometric view has been shown over here. And what we did exactly, now we found this, not exactly we means I didn't did anything over here. Professor Prakash Ghosh has did this part in association with Nitin Sharma and Chetan. I did something different, and they did for me. They helped me this one billet, and this billet has to pass through on the skid. And this is outer refractory body because it is high temperature condition it is there, although it is below the recrystallization temperature, but it is temperature is too high. So we want to see the billet once it's passing through, what is the temperature profile about that, and how much time it should be. Because this furnaces has been designed in such a way that if we'll take this billets for 30 minutes, 1 hour, 2 hour, then their production line is going to be stopped. And what should be the production line, how much time it should be on that billet should be in a heat furnace. It will improvises the productivity, because it will go on increasing the heating, and with that heating condition it cannot be rolled. And at the time of heating condition, if it is going to be rolled, the rollers are going to fail. So a continuous water spray is going on. And if you go on continuous water spray due to the oxidation, they have some scrap is going to be made at the above. And due to those scrap, it also comes in ton. So that is also reduces the total volume or total weight. If it is changing or reducing that, the total weight also affecting the total productivity of that plant. Likewise, so many things has to be optimized during the process. So these are the numerically it has been calculated, and this numerical calculation, what is the temperature distribution, we have provided them, and these are the fuel conditions which has been shown over here. It is not necessary at all, and rather I am showing here some cases, 5 different cases they have given us, like 120 minutes, 90 minutes, or the fuel combination has been given. The burners is going to be fueled. These are the, and the fuel flow rate has been given, and all this having 30 minutes, and this 30 minutes, 60 minutes, 90 minutes, the slabs will be inside the burner. And due to this inside the burner, it will increase the based on the fuel rate and the burning rate, how it is going to affect the temperature or the temperature distribution. Static temperature distribution has been shown, because the burners are not exactly the some of the top face of the billets are going to be more, the temperature is be more, and the core side may be less. So in order to do so, we found out some thermal stresses or slab temperature. Out of that, some optimal values have been obtained, and from this optimal value we have corrected with their final data they have been given. And what are the predictions are given by us, they are exactly doing with that. And we are trying to make them, help them in such a way that if we do such kind of solution to them, the same static solutions can be utilized to replicate this RHF. And anything happen within the RHF, if any burner is not going to work, then how the temperature distribution is going to happen, and how it is affecting the whole process, it can be obtained from there. So these are the some example I have we did at during our this the small course we did, and based on that these outcomes has been shown. Similarly, on the drone, we also did a part of that. Like exactly, if we'll go to the drone part, drone agro health, in that here in NIT Rourkela many people are doing, and under me also some people are doing, but it is the numbers are less as compared to that. I'm bit more interested to see some structural kind under this drone. If you see, the drone have four different major part like frame, propeller, motors, and electronic speed controller. These are the major four components which has to be there. So they can be used either drone aerial imagery, imagery and collaboration with agriculture or online database data augmentation. These are the areas which can utilize. So the data which will have, you can process it, and annotation, labeling, model training, model interfacing, like that you can do. Again, by what are the data you have, if you make it by machine learning process, it can give you some understanding or some type of, you can say, conclusive understanding from there, what kind of work you are trying to do. So data annotation and labeling, if you could able to do, then you can play with the m- all these kind of designs. And one of them is a model training. And model training, these are the some kind of softwares people are using, which are, or the models are being utilized for this kind of analysis. And model interfacing, I'm not exactly going to that much, rather I'll go to another part. It is just the sake of all these points which is necessary to do the interfacing. So, incorporating our drone with collaborating data, first with the help of onboard camera, if you have, or we must have, we capture the video, and a group of people were working with me, but we have not added with the IP address because that fellow is not ready to do so. So we have taken the images and we did our own at our lab. So the classification of the based on drone, we worked out of this some classification. One is a racing drone, one is payload carrying drone, one is equipment carrying drone. Initial, these are all different kind. And camera and sensor. When I was saying equipment carrying drone, we our group worked on this mostly, not these two. And the initial design, based on this first last one, if you design idea, initial design idea, our students had did this one. And they exactly what they did, if you see this drone, there are one, two, three, four beams are there, and exactly one of the beam has been made. And that made, whatever the material it has been utilized, they have used numerical investigation converted on structural or optimization of the drone arm. They utilize different material, its thickness, by changing its geometry, it's finding out the stresses. They found what are the parameters they got from here. You see, the mass, initial mass was 25.20. Then what they did, design one, this is the first design one, then design two they did. They changed the design, by which, if you see the last one, you see the first one, the mass is now 16.36 gram. Earlier one, the 25.20 gram. So the same material, but everything is same, only design has been changed. So the total weight of the drone has been changed, or it is going to reduce the total weight. Then the third design they have did, and based on that, you see the value again further reduced without changing the much on the maximum equivalent. If you check this maximum equivalent, the last one is 5.74 MPa, the second one is 2.521 MPa, and the first one is 1.7584 maximum. And maximum total deformation in the first is 0.364, second one is 0.473, and the third one is 1 point. That means maximum total deformation it is able to take maximum. And the load carrying capacity, if the stress is high, that means the load carrying capacity is high. So based on that, they proposed some drone arm and central body accordingly, and some of the analysis has been done. I'm not, since the work is in progress, I'm not going to show you much on that and what extra they have did. Now, benefits of the drone technology in the agriculture, it is one of the component will help to make this digitwin, enhance monitoring because it is necessary for the images, increase productivity, enhance data collection, data driven insight. And application of the drone technology in agriculture may help in crop monitoring, precision agriculture, irrigation management, and these are all as the one of the hand in hand kind of technology, you can say. When we are talking about the digitwin is not a single one which can able to do everything, which is associated, it's an umbrella under which many things can be done, and out of which this agricultural industry, again under this agriculture industry, under the umbrella of agriculture industry, under the umbrella of um, not only, if I'll go to the warfare or defense industry, they are also very much useful. The drone is very much useful. At that time the payload is necessary. At that time the camera imaging is necessary. So all different kind in combination also different or differently able kind of component according to the industrial purposes. As the purpose changes, the industry changes, the kind of design and requirement changes. So the precision pumping, harvesting, all these points has been associated with that. And the future trends, I believe these are all we have already discussed: AI integration, automation and robotics, data analytics and insights, advanced battery technology. Yeah, although I have not discussed anything battery technology, only I have talked about the battery heating. And you might have heard this electrical vehicles are got fire because this battery technology improved weather resistance. All these points, and role of, again, what kind of joints you are using during the design. According to your problem, you can add this in your analysis or wherever you want. So these are the some points which has been shown, and these are last one, as I said, this is the adhesive technology, as I am working on that. So I have shown that, and thank you. If you have any question, I don't know how much I could able to complete in that. Thank you again.
Dear participants, is there any question or queries? Please ask. Sir will address. Umashankar Pani, is there any question, queries? Or queries? Thank you so much, sir. After inviting after receiving our invitation, you agreed to deliver this talk. We are very much thankful as well as grateful to you. Thank you, sir. And this is actually very need essential things in Industry 4.0 as well as tends to Industry 5.0 or 5.0. So digital win is a necessary component for both the smart manufacturing or smart factory. So everybody should know this thing. Every mechanical engineer should know this thing. Thank you so much for your
Thank you, madam.
essential talk or good talk. So thank you so much, sir.
Thank you, madam.